Good morning or good day. This is a video on what I call the dirty little secret of elements. It's really the general information about elements. By this time, you should have been on the page that you see. You should have also downloaded the PowerPoint presentation, which is right here. And of course, you're watching this video. So I'll start the PowerPoint presentation, if I can. This, I will try to go through a lot of this without actually reading it. Basically, what this is saying is I stole the video or the PowerPoint presentation from Pearson, I don't know what they're called, company, and I give them credit, and when I change it, I have my name in it, the slide that is. The other thing you need to know about this PowerPoint presentation is the ending of it we won't discuss because you will discuss it. It's called How to Calculate Atomic Masses. You'll be discussing it in a different video. This page is basically saying that the dirty little secret is elements don't exist. Those things that people have told you are one thing are actually not one thing. They're actually made up of several things, depending on what element. It depends how many different things there are that we consider to be one thing. And the things that do exist are what are called isotopes. By this time, hopefully you have defined an isotope. It's an atom of the same element, except they have different masses. So it's an updated version of Dalton atomic theory that says atoms of the same element are the same, including mass. Well, we found out that's not true. They're different by mass. So here's what is the mass difference? Well, it's actually the number of neutrons. So the number of protons and the number of number of protons and number of electrons in all isotopes of the same element are the same. The only difference is the number of neutrons. So they they being chemist people and other scientists, have a way of showing isotopes. So you can't just show the element because we're basically lying to everybody to say the fact that this one thing is, these multiple things are one thing. So what we have to do is we can't use simple symbols of the the element. We have to use other parts of the symbol. So what we do is there's actually 3 ways you can show an isotope. They're all based on the symbol of the element. For example, sodium, there is an isotope of sodium, which is sodium 23. So at the bottom here, these are the non-technical ways of writing it, which is the element's name dash 23, or Na, the element symbol dash 23. The more correct way of writing it is like this, where you have the chemical's element symbol. Above you have 23, which is the isotope's mass number, and below is the atomic number. So that's a superscript and that's a subscript, and it's on the left side of the material. Okay, just a reminder, the atomic number is this is wrong. This should not say atomic mass. It should say atomic number. Whoever did this did it incorrectly. So we rewrite this as atomic number. It has a symbol Z, and it's the number of protons. If you look on the periodic table, each block in the periodic table is an element, and in each of those blocks is always a whole number, and that whole number is actually increasing by 1 each element as you go through the periodic table. That's the atomic number. The mass number is never shown on the periodic table, and what it does is it's the number of protons and the number of neutrons. So the mass number is the way you show different types of isotopes, because it includes the number of neutrons. So if you simply subtract these two numbers, you get the number of neutrons. And as I said, the difference between isotopes in the same element is the number of neutrons. The mass of a neutron is the exact mass of a proton. So those are the symbols for subatomic particles, which you knew. So here's a breakdown of, and this is very common, of subatomic particles and isotopes. So again, you have the atomic number, which is the number of protons. The number of electrons is equal to the number of protons because it's an atom of an element. An element has no charge, and then therefore the number of neutrons, which is different. The only difference was they're not isotopes. The only difference between isotopes of element is the number of neutrons. So that's what the mass number is important for. Is you can figure out the number of neutrons from the mass number and the atomic number. So that's pretty simple. And again, this isn't just different ways of actually doing. If given the symbol of an isotope, you can figure out the number of subatomic particles in the isotope, and you can check these yourself. Okay. The isotopes themselves are in a different percentage, which is called relative abundance, for different isotopes of the same element. So here's an example of the isotopes of magnesium in this 3. There's magnesium 24, magnesium 25, and magnesium 26, and it shows you the only difference is the number of neutrons. And we will talk about this in when we talk about how to calculate atomic masses. The main reason why we lie to everybody and tell everybody that there's only one thing called magnesium is because all the isotopes of magnesium act chemically the same, because as you now know by now, the definition of chemistry is not the study of matter, it's the movement of electrons, and every isotope of magnesium has the same number of electrons, so they all chemically act the same. But the other thing you need to be able to take these isotopes and make pretend they're one thing, basically lie to everybody and say that they're one thing, besides the fact they chemically act the same because the number of electrons is the same, the other thing is they always must come in the same number set. That's what this relative natural abundance is there. And for these isotopes, it's always approximately like 79% magnesium 24, 10% magnesium 25, and 11% magnesium 26. And they always come in that ratio. And since they have a set number ratio, and they all act chemically the same, that way we can actually combine them and tell everybody and make pretend that there's only one thing called magnesium, the element, which of course is a lie. And we'll get more into that again in the slide on which we talk about how to calculate atomic masses. So in summary, elements don't exist. They're made up of isotopes. The only difference is the number of protons, and they all act chemically the same. And what you'll find out is that, well, even though we know that the element is made up of multiple things, we'll still treat it like one thing, because in our chemistry, all the isotopes act exactly the same, and we'll make pretend that there is only one thing. Thank you.